Hello, can you see my screen now?
Perfect, thank you.
Okay, I will start. Hello, everyone. This is Dr WANG. I'm from Changshu Institute of Technology. And last year, September, I went to University of Birmingham and worked with Professor Pham and also the other colleagues. Here, I'm going to introduce a study on the real-time permutation Photoshop problem in car disassembly line. This study aims at minimum the time cost in car disassembly line with finding the best online sequence. The definition of real time comes from the disassembly time was uncertain for each car's specific moving part. In this study, a disassembly line with 14 workstations, which means there has 14 parts to be removed from a broken car. And there has two boundary conditions in this problem. First, it's a single disassembly line and has no flexible to exchange positions of cars when they were set online. Second, the online car must wait for the previous car to finish its disassembly work. The main job for this study is to achieve the minimum time with changing the online sequence dynamically. For example, at 68 minutes from car 18 to car 10, they were online cars. They were already online. If the real disassembly time for the car 5 at its working station 4, which means the fourth part of the car 5 will be removed at this stage. When this time was updated, when at this time, only the offline cars could be rearranged because some cars have already online and started removing parts maybe 1, 2, 3. We built a model by Simulink, which be able to carry out the online optimization, which mentioned above. First, the starting date, which means the disassembly time for each car's every part was rough inspected by the skilled engineers, and they contributed into a matrix. Then the first optimization was carried out to decide the best online sequence. At stage 3, the real disassembly time for the specific part was updated. For example, if we are in a factory, it could be realized by the sensors on the disassembly line. At stage 3, we detect the updated time and we got a new matrix. Then at the last stage is the new best sequence, which comes from the optimization within the offline cars could be achieved. For the real-time optimization, we found a same optimization algorithm was not suitable for all situations. At first, all cars should be considered to do the optimization. At the process, only parts of the cars do the optimization, depends on they were online or not. Hence, an adaptive optimization algorithm was needed. We used the B algorithm to realize online optimization. It's called the adaptive spiral Bayes algorithm. It had a feature to do the global searching and the local searching with different scale. Depends on the number of offline cars. Here were our results. We got a best sequence after the first optimization. Then, if the real disassembly time for the car 3, when it needed to remove the third part, when its time was updated from the 8 minutes to 18 minutes, the 8 minutes was rough inspected by the skilled engineers, but the 18 minutes is the real cost time. When the data was updated, the offline class we can determine from here to here. It could be rearranged. Then we got the new order. The proposed adaptive spiral B algorithm realized local searching as the shape of the spiral, then conducted the optimization with distinguishing whether the vehicles to be disassembled were entering the disassembly line. Second, the method proposed in this study was suitable for solving the same kind of real-time permutation Photoshop problem in the assembly line or disassembly line. This study was finished together with Dr. Murat, and I heard he got a fever, high fever yesterday. I hope he can get well as soon as possible. And also we got a lot of advices from Professor Dr. Wang. Thank you a lot. That's all.
Thank you very much, Dr. Wang. Very nice to have your presentation.